Math Grade 4 Module 5 Lesson 39 Fraction Equivalence Ordering and Operations. Topic G. Repeated additions of fractions as multiplication. Objective. Solve multiplication, comparison, word problems involving fractions. Fluency practice. Multiplying mixed numbers. Break apart 3 and 3/8 as an addition sentence. So we're going to use this using addition. So first we're going to rewrite 3 and 3/8, and we're going to break apart the 3 wholes and the 3/8. Next, we're going to multiply 3 times 3 and 3/8. And now we need to find the unknown, and that's where we come up to here. So now we're going to start filling in for the unknown. So let's look at our whole numbers first. We're going to first multiply 3 by 3. And our fractions over here, we're going to multiply 3 times 3 again over 8. 3 times 3 we know is 9. And then we're going to multiply numerators. 3 times 3 again is 9. And that's going to leave us with 9/8. But there's a problem. It's an improper fraction. So we can pull out 1 whole. And so 8 minus 9, well, that leaves us with 1/8. We can now add that to the 9/8. And that's going to leave us with a grand total of 10 and 1/8. Let's look at the next problem. So again, we're multiplying mixed numbers. So here we have 6 times 3 and 2/3. So again, our first step is going to be to decompose. So we're going to have our 3 wholes plus our 2/3. Next, we're going to multiply everything out by 6. And so we're going to use that distributive property like we've been talking about for the past few lessons. So we're going to multiply 6 times 3 and 6 times 2/3. 6 times 3, that's equal to 18. 6 times 2/3, that's equal to 12/3. Now again, we have an improper fraction. And we know 3 goes into 12, well that's 4 times. So each time we pull out a 3/3, we have a little bit left. And then we get up to here, we're up to 9/3, and then that's going to be 12/3. So now we can now add the 18 plus 4. And that's going to leave us with 22 as an answer. Concept development. Problem set. Problem 1. Tammy ran 2 5/8 miles. Her sister ran twice as far. How far did Tammy's sisters run? So first we're going to draw this out. We know Tammy ran 2 5/8 miles. We don't know how far her sister ran. All we know is her sister ran twice as far as Tammy. So we know the sister at least ran 2 5/8 miles. And on top of that, so the first step we're going to do, we're going to take the 2 5/8 and we're going to decompose it. We're going to break this down. So we have 2 5/8 written out. And now we're going to decompose this. We have 2 wholes and 5/8. And now we're going to multiply this by 2. So we're going to do our parentheses so we can go ahead and distribute this throughout. 2 times 2 is what? Well, that's 4. Plus 2 times 5 is 10. And we leave our denominator. So that leaves us with 4 and 10/8. But the problem is that, hey, that's an improper fraction. And we all know an improper fraction is greater than a whole. So we can pull out 8/8, and that leaves us with 2/8. And now we can go ahead and convert this over to 1 whole. So now we can go ahead and add this to the 4. So we have 4 plus 1 and 2/8. Nothing adds up in the numerator, so the 2/8 just carries. Plus 4 leaves 5 and 2/8 miles. That's how far her sister ran. So here you go, concept development for problem set. Problem 2. Natasha's sculpture was 5 and 3/16 inches tall. Maya's was 4 times as tall. How much shorter was Natasha's sculpture than Maya's? So first off, we're going to draw this out. So we know that, hey, Natasha's sculpture was 5 and 3/6 inches tall. We know Maya's sculpture was, boom, 4 times that. So we don't know her total, but we can automatically assume that, hey, she has a sculpture. We know it's 5 and 3/16 tall minimum. And it's going to be 4 times bigger than Natasha's. So we need to find this difference. So first thing we're going to do is we're going to start by solving our problem. That's always a good place to start, right? Right. All right. Pen's working. Pen is now working. So we can multiply. So we see that this is 3 times bigger. So we're going to multiply 3 times 5 and 3/16. First thing we do, decompose. We have the 5 plus the 3/16. Now we're going to multiply everything by 3. We're going to go ahead and distribute that 3 throughout. So 3 times 5 is 15. And then 3 times 3/16 is going to be 9/16. So we know that Maya's sculpture is 15 and 9/16 inches tall. Concept development problem 3. The seamstress needs 1 5/8 yards of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. How many yards of fabric does she need for both dresses? So this question is really asking us to find the total. So we know a child's dress takes 1 5/8 yards of fabric. And we know a woman's dress takes 3 times that. We need to know the total. How many yards of fabrics do both dresses need? So first thing we're going to do is we're going to look at this. There are 4 units because, again, we're looking at the grand total of things. So we have 4 units, and we're going to times that by 1 5/8. Again, decompose this into its base parts. And now we're going to multiply this by 4. Because, again, we're going to distribute the 4 throughout. 1 times 4 is 4. And then 4 times 5/8 is equal to 20/8. Now, with this, we know that 20/8 is greater than a whole. And so we're going to, again, start pulling out eighths. So we pull out 1/8, and that leaves us with 12/8. We pull out another eighth, and that leaves us with 4/8. So we pulled out 2 wholes. So now we can add this all together. So we have 4 plus 2 4/8. We add that up. 4 plus 2 is 6. And then that is going to be 4/8. And then we know that, hey, we can go ahead and simplify this. We divide this both by 2 because both even. Our 6 wholes stay the same. 2 goes into 4 2 times. 2 goes in 8 4 times. And again, hey, I can divide this again. Divide this by 2. So that leaves us with 6 and 1/2. Problem 4. A piece of blue yarn is 5 2/3 long. A piece of pink yarn is 5 times as long as the blue yarn. Bailey tied them together with a knot. They used 1/3 yarn from each piece of yarn. What is the total length of yarn tied together? So here we go with this problem. So we have how many units? We have, let's count them with me. We have, was it 1, 2, 3, 4, 5, 6 units. And we know that Bailey's going to use as part of this string to tie a knot. So we can start off by simply multiplying 6 times 5 2/3. We're going to decompose this just like we've been doing all day. And now we're going to multiply. So we're going to distribute that throughout. And so when we multiply this, we're going to get 6 times 5, which is 30. And then we have 6 times 2, which is going to be 12/3. And that's going to be greater than a whole. So we know out of here we can remove, 3/3. Now this is 6/3. This is 9/3. And now we can get, 4/3, 4 wholes, which is 12. So we can now add this up. So we have 30 plus, because we got 1 hole, 2 holes, 3 holes, 4 holes, plus 4, and that's going to give us 34. But we're not done. Aha! So we have to take away the 2/3, because remember, she used a 1/3 from the blue and 1/3 from the pink. And so if we add that up, we're left with 2/3. We now have to account for that. So we're going to do 34 minus 2/3. But guess what? We can't subtract Nothing. So we have to go over here and borrow. So this 34 is going to be rewritten as 33 and 3/3. Because again, that's our whole. So again, we're going to borrow. So that leaves us with 33 over here and 3/3. Now 3 minus 2, that's going to be 1/3. And our whole carries down. So the total length in yards was 33 and 1/3 yards.